This is the fifth video of the tutorial about history analysis in RJ1. In this video we will learn how to get the rays for a given path and how to get the path for a given ray. Remember that paths are defined by interaction sequences. This image shows 9 rays, which are grouped into 2 paths. So a path can be thought of as an equivalence class of rays. Every ray belongs to a single path, and every path may refer to a single or multiple rays. We want to get the rays for an individual path. And in order to do so, the first thing that we have to do is to tell the history detector that it should collect the ray data. In a previous video, we already have seen the command history settings record paths equals true, and in a similar manner, we now make the setting history.settings store all ray data equals true. In a later video about the history settings, we will exactly understand what this means, but for the moment it is enough to understand that this command is required whenever we want to get rays from the history detector. So let us run the ray tracing with these history settings. And this time the history detector will collect the paths and it will also collect the ray data. So next, let us get a path collection. With history get paths. And from that path collection, we can pick an individual path with standard Python list notation. Path in singular is paths and then some index. And we can print the result to see what we got. So we have picked a path with 2,500 rays and a total flux of 0.039. So for this path, we now want to get the rays which belong to this path. And the command that we need is History.GetRayCopies. And then as an input argument, we give the path. Let's check the result. And it returns a ray collection which has in fact 2,500 rays. You may wonder why the command is called History.GetRayCopies instead of simply History.GetRays. And the reason is that this command does not return the original rays that have been used during ray tracing, but instead it returns a collection of new rays which are initialized with the properties that have been stored in the history detector. It is typical for commands of the history class that they have several overloads, and also the getRayCopies is no exception. So we could also have used getRayCopies. We could have used this command without any input argument, then we would just have received a ray collection with all the rays that have been traced, or with copies of all these rays that have been traced. We can use the command with a single path as the input argument. This is what we have just done. We could have provided a path ID, which is an integer number instead of the path. We could have provided a path condition or a path collection. And in either case, the returned ray collection is just the union of the ray collections for the individual paths that are in that path collection or that comply with the path condition that we could have provided. And finally, we can provide a ray filter. In that case, we start from all the rays that have been traced, and then these are filtered with the given ray filter. But for the moment, let us just stick to the flavor of this command where we provide a single path as the input argument. As a little application example, let us now study the average optical path length of all the rays that belong to an individual path. So we start by looping through all paths, or maybe we just consider the first 10 paths in the path collection. And for each of these paths, we first get the corresponding ray collection. We then define a list of optical path lengths. And we now loop through all the rays in that ray collection. Get the optical path length for the individual rays. And append it to the optical path lengths list. So after this loop has run, this list contains all the optical path lengths for the rays that belong to this given path. And then we can evaluate the average of that list. So let's see. Yeah, as we can see, for each of the paths, or for each of the first 10 paths, the optical path length in millimeter, or the average optical path length in millimeter, has been printed to the console. So this was about getting the rays for a given path. We can also ask the other way around. We have a given ray and want to get the path that belongs to this ray. To this end, we can rerun the ray tracing simulation, but with the ray collector. That just collects all the rays during ray tracing. Need to rerun the ray tracing, obviously. And from that ray collector, we can get a single existing array. Maybe just array number 100. And now we may want to check what is the path that belongs to this array. And here the command is History.GetPath. So before we had History.GetPaths, and now we need History.GetPath for this array. We could also get the paths for array collection. So if instead of an individual array, we would have started from array collection. So maybe the first 500 arrays. And put this into array collection. Then we have a smaller array collection from the total array collection. And if we want to know the paths for this array collection, we use the command History.GetPaths. And this can be used with array collection. So this does not return a single path, but a path collection, because all the arrays in the array collection may not all be in the same path. So this is just the union of the paths that we would get for the individual arrays in the array collection. So this was the video about getting the arrays for an individual paths and getting the paths for individual arrays.